Lesson 5, Virtual SAN Data Stores. By the end of this lesson, you should be able to explain the purpose of a VMware Virtual SAN data store, describe the architecture and requirements of a Virtual SAN configuration, describe the steps in configuring Virtual SAN, and explain how Virtual SAN storage policies are created and used. About Virtual SAN. Starting since vSphere 5.5, VMware introduced software-defined storage with Virtual SAN data stores. Virtual SAN is a hybrid storage system that leverages and aggregates local solid-state drives as cache and local hard disk drives to provide a clustered data store that can be utilized by virtual machines. In a Virtual SAN environment, a number of ESXi hosts are configured to form a Virtual SAN cluster. All the ESXi hosts communicate together through a dedicated Virtual SAN network. Most of the hosts have local hard disk drives and local SSDs. Hosts without a local hard disk drive can share their compute resources and take advantage of the clustered storage resources. Local SSDs can optimize the use of storage on each host. The hard disk drives and solid disk drives are combined on each host to form up to 5 local disk groups. A disk group includes at least one solid-state drive and up to 5 hard disk drives. The disk groups of all the ESXi hosts in the Virtual SAN cluster are combined to create a Virtual SAN data store. Only a single data store exists per Virtual SAN cluster, so it contains all hard disk drives and solid-state drive resources for the cluster. The object store file system enables the VMFS volumes from each host to be combined and mounted as a single data store. This data store contains all the virtual machine files, including the VMDK files. Each of the VMDK files have a different virtual machine storage policy created that defines how data is stored on the disk of the data store. These virtual machine storage policies are configured to take advantage of the capabilities of the Virtual SAN. Virtual SAN requirements. To start with a Virtual SAN, you need to have a machine running vCenter server. This is necessary because it uses that for the Virtual SAN to fully integrate into vSphere. A Virtual SAN cluster must have a minimum of 3 ESXi hosts that contribute capacity to the cluster. A host cannot participate in any other cluster besides the Virtual SAN cluster. Each Virtual SAN cluster requires a dedicated network that each host can communicate with. VMware recommends a 10 gigabit network card, preferably with a NIC team of 2 10 gigabit NICs for fault tolerance. They have tested it and a 1 gig will work, but it's not recommended because the size of the network is not supported. All of the hosts in the cluster do not have to have local storage, but remember you got to have 3 hosts that's contributing to the storage. So you need at least 3 hosts that have hard drives or hard drives that will participate in this cluster. A host without storage is used for its compute resources while it's leveraging the Virtual SAN data store. All hosts that have local storage must have at least one solid-state drive. A host cannot have a hard disk drive locally and participate in the Virtual SAN cluster. The solid-state drives must take up at least 10% of the total storage. Configuring a Virtual SAN data store. We set up the Virtual SAN network, we enable the Virtual SAN on the cluster, and we create our disk groups, and that can be manual or automatic. If the Virtual SAN is configured in automatic, then all the local disks are claimed by Virtual SAN for the creation of the distributed Virtual SAN data store. So all your disks on your ESXi host will get used. If it's configured manual, you manually select the disk to add to the distributed Virtual SAN data store by creating disk groups. The default mode is automatic. The Virtual SAN scans all hosts for empty disk. When it finds these empty disks, it configures them for Virtual SAN. Vsicm6 is the only version that supports the Virtual SAN cluster. Configuration for Virtual SAN can only be done through the vSphere web client. And when we're in here creating the new cluster, give it the name, the location, if you want to turn on any vSphere features, and then vSAN is one of them, or virtual SAN. And then we click OK. Disk groups. Each ESXi host that contributes its local devices to a virtual SAN cluster, the devices are organized in disk groups. A disk group is a unit of physical storage capacity on a host and a group of physical devices that provide performance and capacity to the virtual SAN cluster. The disk group of all ESXi hosts in a virtual SAN cluster are combined to create a virtual SAN data store. The size of a virtual SAN data store is governed by the number of hard disk drives per ESXi host and the number of ESXi hosts in the cluster. The virtual SAN data store is used to store virtual machine files, including virtual machine disk, or VMDKs. Remember, it requires one flash device, one hard drive, or solid state drive. It can support up to 7 devices per disk group. You can have a maximum of 5 disk groups per host. In the vSphere web client, you can use the summary tag of a vSphere cluster. It displays the virtual SAN information. You can see utilization of the host right here. And then in the little pane right here, we have the virtual SAN. And it tells us we can add disk to storage as manual, 8 hosts, 8 of 8 solid state disk drives are in use, 16 are eligible. We have 76 gigabytes total, and 66 are free. Using virtual SAN. After you enable virtual SAN on a cluster, a single virtual SAN data store is created. This data store appears as any other type of data store on the list of data stores that might be available, including virtual volume, VMFS, and NFS. A single virtual SAN data store can provide different service levels for each virtual machine or each virtual disk. In vCenter Server, storage characteristics of the virtual SAN data store appear as a set of capabilities. You can reference these capabilities when defining a storage policy for virtual machines. When you later deploy virtual machines, virtual SAN uses this policy to place virtual machines in the optimum manner based on the requirements of your virtual machine. Objects in a virtual SAN data store. In a virtual SAN data store, files are grouped into 4 object types. You have namespaces, virtual disk, snapshots, and swap files. So it's really no different than normal VMFS volume. Virtual machine storage policies. Virtual machine storage policies are a set of storage properties that are configured by an administrator to be used by virtual machines. Each of these storage policies is created to reflect a set of capabilities that meets the availability, performance, and storage requirements of some of the virtual machines in your environment. These storage policies are created in advance of the deployment of virtual machines. When a virtual machines are deployed, the administrator chooses the VM storage policy that meets its requirements for the creation of its VMDK file. Configuring virtual machine storage policies. So here we are in the wizard for creating new VM storage policies. We give it a rule set based on the capabilities of vSAN. We can add a capability, whether it be the number of disks per object, the flash read cache reservation, number of failures to tolerate, type of provisioning we want to force, and the object space reservation. The capabilities of the VM storage policies reflect the level of redundant array of independent nodes, RAIN, support that they offer. Storage policies define how objects are configured to offer availability. Viewing a virtual machine's virtual SAN data store. The consumption of virtual SAN storage is based on the virtual machine's storage policy. The virtual machine's hard disk view, and this is inside of where you look at edit a virtual machine. We can see right here we have our size with our disk, and we can pick the drop down on the storage policy we want it to use. This shows us the actual VMDK file where it's living at on the virtual SAN. Disk management. Disk management in the vSphere web client. You can easily map the location of magnetic disk and flash-based devices. You can mark disk and controller LEDs. Light LED on failures. This is when a solid-state disk drive or a magnetic disk encounters a permanent error. vSAN automatically turns the disk LED on. Turn disk LED on or off. The user might need to locate a disk so virtual SAN supports manually turning a disk light on or off. So if you're in there and you're like, well, which disk was that I want to remove, you can turn it on and it'll come on for you and blink or whatever, so you can identify that's the drive that I was seeing in the GUI. Marking a disk as a solid state drive. Some solid state drives might not be recognized as SSDs by Vsicm6. These disks can be tagged or untagged as SSDs for cache. Marking a disk as HDD. Some solid state drives or magnetic drives may not be recognized by Vsicm6 as hard disk drives. Disks can be tagged or untagged as hard disk drives. Solid state drives must be marked as hard disk drives in order to be used for capacity. So if you had a solid state drive and you didn't want to use it for caching, you would need to flag it as a hard disk drive if you want to use the space on it. Adding disks to a disk group. Disk groups can be expanded by adding data disks to a node and adding these disks to a particular disk group. The vSphere web client shows any unclaimed disk in the maintenance window. So if right here we got our disk group, you click on the add disk icon, you'll see right here on this window that we see, oh, there's one that's available. So we can add it and expand the disk group. Removing disks from a disk group. When you remove a disk from a disk group, you can choose to have it evacuate the data before removing the disk, or the host must be placed in maintenance mode. When we evacuate the data, it's going to move it with this checkbox. It'll move it to another disk that can contain the data that you're wanting to save. Virtual SAN cluster member maintenance mode options. Before you shut down, reboot, or disconnect a host that is a member of a virtual SAN cluster, you must place the host in maintenance mode. When you place it in maintenance mode, you can select a specific evacuation mechanism. When a member node of a virtual SAN cluster enters maintenance mode, the cluster capacity is automatically reduced because the member node no longer contributes storage to the cluster. And our option, if you want to ensure accessibility, it moves enough components to ensure operational integrity of objects. Full data migration, all components are evacuated from the host. No data migration, no action is taken, which can result in degraded objects. Removing a host from a virtual SAN cluster. To remove a host that's participating in a vSAN cluster, place the host in maintenance mode, delete the disk groups associated with the host, and then remove the host from the cluster. You should now be able to explain the purpose of a VMware Virtual SAN data store, describe the architecture and requirements of a virtual SAN configuration, describe the steps in configuring virtual SAN, and explain how virtual SAN storage policies are created and used.